Good morning, friends. Welcome to Water Resources Engineering class. In today's lecture, we discuss on infiltration, infiltration capacity. What is infiltration? Infiltration is the process by which water on the ground surface enters the soil. You know already the hydrologic cycle. So in the hydrologic cycle, infiltration is one of the important components. For example, if I take this is a catchment area. This is a catchment area. How the inflow will be there to this catchment area? Naturally by precipitation. So this is the inflow. And there will be some outflow which we call it as runoff. So this inflow may be the inflow flowing in the river plus precipitation altogether. The outflow is runoff. So from inflow to runoff, there will be some quantity of water which will be infiltrating, which will be percolating, which will be moving down into the earth's surface and reach the groundwater. And this component is what we call it as infiltration. So that is the quantity of water that percolates into the ground and reach the groundwater is what we call it as infiltration. And it is one of the very important component of hydrologic cycle. So what I left apart from this, evaporation I have left, evapotranspiration I have left, some depression storage I have left. So they are all moving up, basically evaporating. Whereas infiltrating means moving into the earth's surface, that is what we call it as infiltration. So it is the process by which water enters the groundwater, the ground surface is what we call it as infiltration. And it is definitely one of the most important components of the hydrologic cycle actually. Then what are the stages of infiltration? For example, when rain falls on a dry area, for example, the dry area, naturally first rainfall when it occurs, the whole thing, whatever that fall on the earth's surface, the ground, everything will be infiltrated. Everything will go into the earth. So that's why infiltration is rapid when the ground is dry. Whereas suppose the rainfall will be for a continuous period of 1 hour or 2 hours. Then in that case, as the time progresses, that whatever the infiltration, that rate at which the water enters into the soil goes on decreasing. Initially, the infiltration rate is very, very high. Whatever it comes onto the ground, everything will be infiltrated. But as the time progresses, what will happen? This infiltration rate goes on decreasing, and it decreases exponentially, and it becomes constant after a certain time. That is why it decreases water, and this decrease also, kindly remember, it is at the exponential rate, and after some time, naturally it reaches to the steady state. So that means constant rate of infiltration after that. So this is how the infiltration takes place into the ground surface. If the soil is dry, initially the infiltration rate is nothing but actually how much is entering per time, unit time. So the infiltration rate will be very, very high at the beginning of the storm, and as the storm continues, the infiltration rate goes on decreasing exponentially, but after some time it reaches to a constant rate of infiltration. And what is infiltration capacity? The infiltration capacity means the maximum rate Please remember, it is the maximum rate at which the soil can absorb water. It is the maximum rate at which basically the soil can absorb water. Naturally, at the beginning, naturally the infiltration capacity is very, very, very high. As that's what the maximum rate at which water enters into the soil, water absorbed by the soil, is what we call it as infiltration capacity, and it is expressed always in terms of per hour or centimeter per hour. What is the other thing which we will express in per hour or centimeter per hour? Rainfall intensity. Rainfall intensity is expressed in per hour or centimeter per hour. Similarly, infiltration rate or infiltration capacity is also expressed in terms of per hour or centimeter per hour. Suppose when rainfall intensity is more than infiltration capacity, rainfall intensity is high compared to infiltration capacity. What is infiltration capacity? The maximum rate at which the soil can absorb the water. Suppose if the rainfall intensity is more and the infiltration capacity is less, then what will happen? So much of water flow on the ground, and that flow is what we call it as runoff. So that's what we call it as excess water. For example, if the rainfall intensity is less, slowly the rainfall is taking place. The intensity means per hour, so much of depth per time. So if the rainfall intensity is less compared to the infiltration capacity, the entire water actually infiltrates into the earth surface, into the ground surface. The entire water is being absorbed by the soil. Then in such a case, the runoff is zero. For example, runoff is equal to 0. So this is the basic beginning things that you need to understand. But what are the factors which govern the infiltration capacity or infiltration rate? You call it as infiltration rate or infiltration capacity. Anything is fine. But the best wording is factors affecting infiltration rate is the correct wording. So there are 12 factors which we mentioned. Let us see one by one. Soil type and size, for example. So what is the type of soil? For example, if the size of the type of the soil is where basically it is like what you call it as a granular soil, where the grain size is high, like sand, for example. The grains, that means independent grain like soils, sandy soils, then naturally infiltration is high. So remember, in a granular soils, the infiltration rate is higher. Right, naturally that is. Whereas if you take a clay soil, for example, clay soils, if you take it, the infiltration rate is less actually. Please remember, suppose if the soil has swelling minerals, naturally block cotton soil is swelling, it swells with water. If suppose it has, block cotton soil has such type of minerals in it, so in such a case actually the infiltration rate reduces drastically. So that's why once again tell me, what is the soil type and size means? Soil, higher the size of the soil, for example, more the infiltration actually. That is the first thing. Second thing is, for example, if it is a granular soil like sandy soils, then infiltration rate is high. Suppose if you take a clay soil, infiltration rate is less. Suppose if you want to take block cotton soils, so where the minerals are there, so in such a case actually infiltration rate is further less actually in that. So this is the first point. Come to the second point. What is the soil moisture content? Suppose if you take a dry soil, so in the dry soil, naturally whatever rainfall that comes, immediately it absorbs. So the infiltration rate is high. Suppose already it is wet soil, already it is saturated. If suppose rainfall occurs, then in such a case, the infiltration rate is less. So that is the second thing. So dry soil, wet soil. Then what is the condition of entry surface? Suppose if you take it on an area, agricultural area where it is already plowed and ready. So that means the entire top layer of the soil is loose. For example, when the farmer will plow, so naturally he wants to sow his crop. Then before supplying the water to his crop, then naturally he plow the ground. So that plowing has occurred. So that means the top layer of the entire soil is in loose condition. If such a case, actually, if the rainfall occurs, then infiltration rate is very, very high. Or suppose if you take it, if suppose you are walking on a even mud road also, continuously people walk on that mud road. So naturally like a route like it is there. On such a case, if suppose the rainfall occurs, infiltration rate will be less because the top layer is such that it won't allow water to percolate down. That is the next thing. Suppose for example, so on a grass, suppose if you are having a grassland, actually, if on a grassland means automatically what will happen? The bottom soil is in loose condition. When such a case, the infiltration rate is basically high. Suppose vegetation increases infiltration. That's what the meaning of that particular point. Coming to the next point, soil compaction. Suppose compacted soils. What do you mean by compacted soils? Suppose for example, we are walking on a strip. So hundreds of people are walking on a road, actually. It's a mud road only. You are continuously walking. Naturally, the top layer is being compacted. When the top layer becomes compacted, then if the rainfall occurs, the infiltration rate is very, very less, actually. So that is what I mean by, so if the compacted soils have reduced the infiltration rate. Then coming to rainfall intensity and duration. Rainfall intensity means already I mentioned, if suppose if the rainfall intensity is more than the infiltration capacity, then runoff will occur. Whereas if the rainfall intensity is less than infiltration capacity, all the rainwater is being absorbed by the soil. Suppose high intensity rains can exceed in infiltration capacity quickly. If suppose the intensity is very high, automatically it reaches to capacity, maximum rate at which the infiltration takes place very quickly, actually. Land use. Urban areas or paved surfaces where we have made the roads, actually reduces naturally the infiltration and increase the runoff, actually. Percolation characteristics of the soil. For example, what is the percolation? The infiltration will continue only when percolation continues. As long as percolation continues, infiltration continues. The infiltrated water must be transmitted down by force of gravity and capillary action. How the water will reach to the groundwater? By force of gravity it has to reach. That's why characteristic. Then temperature. In summer, actually, if you take it, the soil will be so dry and infiltration rate will be very high. Whereas in the case of winter, the infiltration rate is less. So that is the number. And cultivated and barren lands. Just now also I mentioned, if suppose an area which is completely cultivated land means a plowed land, actually, naturally soil is loose. So naturally the infiltration is higher. Whereas barren land means just like that, that means nothing on that. So naturally it is almost like a compacted layer. So in such a case, on barren lands, the infiltration rate is less, actually. Then quality of water. For example, silt, if suppose the water presents silt or any impurities, in such a case, the infiltration reduces, actually. whereas presence of groundwater table. So in some of the sandy soils where the groundwater table is almost near to the ground, right, in such a case actually the infiltration rate naturally for such a thing normally will be very very less actually. So only because already groundwater table is at that place. So that is one of the presence of groundwater table reduces infiltration. That is one of the important points you should know. Then finally, catchment characteristics. What do you mean by these catchment characteristics? Infiltration capacity decreases with increase in drainage density. The capacity decreases with increase in the drainage density. What do you mean by the drainage density? The length of the entire stream divided by the catchment area. Catchment area means the area which is contributing the water to the stream. That is what we call it as catchment area. What do you mean by Ganga catchment? Ganga catchment means whatever the rainfall that occurs in the entire area, and from there that rainfall is coming as runoff into the Ganga river. So then we call that as Ganga catchment. What is Godavari catchment? So Godavari catchment is along the river on the both sides extended up to so many kilometers actually, from where the rainfall occurs. From all those places the rainfall in terms of runoff, rainfall naturally some part is infiltrated, some part is evaporated, the rest is only as runoff on the surface. It flows towards Godavari, and that is what we call it as catchment. Catchment means contributing. Contributing to what? Contributing to river, contributing to stream. So this is what catchment characteristics means. If suppose the drainage density, that means the stream length, whatever it is divided by the catchment area, if that is increasing, then naturally infiltration decreases. So that, and at the same time infiltration capacity decreases also as the surface runoff is increasing. Suppose if you take a catchment area is like a valley, for example, so this is how the catchment is, and here the stream is there. So naturally more and more water go as surface runoff and reach the stream, whereas infiltration will be less at such a cases. That is what we mean by the catchment characteristics. So this completes to me. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.